how to build your own customized DIY lithium iron phosphate battery. Hi folks, I'm Roger from the Offgrid workshop, and in this episode we will be doing an end-to-end build of a lithium iron phosphate battery. Now we have another YouTube out there, we'll put the link in the description, which is very, very long, extremely detailed and very long, and we realize that for some folk it's just too long to watch, so we are going to condense this but give you all of the essentials so that even if you're a beginner you can do it yourself. The other one we use the JK BMS, in this one we will be using a JK BMS. So let me take you through everything that we are going to do and need. We have standard 280 amp hour lithium iron phosphate battery cells, prismatic cells. We've got 4 of them to make up a 12 volt battery. Each of them is a nominal 3.2 volts and it can be charged up to 3.65 volts, so that makes it a 14.6 volt battery depending on what you set your BMS to. Now each cell is 72 millimeters thick, if you like, so the whole pack is 288 millimeters, and they are 175 millimeters wide and about 200 millimeters deep, excluding the terminals, these studs here. And very, very important that when you arrange them, it's a funny thing, but the lighter colored on all of these cells are the negative terminals and the black are always the positive terminals. It's a little bit the other way around from wiring, that you would normally have black as a neutral or an earth. In this case, black is live and the whiter or lighter colored is the neutral or negative. And very important, you've got to go from, let's say you're going negative to positive, then to a negative, back to positive, negative to positive, and negative to positive. So basically these will be put in series, you'll see shortly, with what we call bus bars. We have taped this up. You don't have to tape it up. If you want to tape it up, then that's fine. If you don't want to, that's fine. We just have them taped up here because they're sort of easier to manage and move around than that. So right, that's the cells. We're going to put 2 ply ends on here. We're going to use these bus bars. We're going to use these thread bars with connector nuts on either end. And we are about to just protect the battery from problems on these thread bars by putting a plastic sheath over the thread, just so that if it ever does make some sort of contact, that we don't have a sharp thread to cut through this bit of plastic covering here. So let's prepare these and then we'll bring the ply ends and carry on.
Okay, so we tend to use birch ply just because it's light and strong, and we use 9mm birch ply, and we glue 2 pieces together like this so that we have a bit of a shelf, which we'll show you shortly. And it also just makes it really strong and it's easier to work with than having a solid piece of like 18mm ply. When you're gluing ply like this, it's essential to put pins on the corners like that, otherwise when you go to clamp them then they slide around, you don't get them completely straight. And then we just mark all the holes out, drill them out using a drill press, and then you're good. Then, as my dad mentioned previously, we use these plastic pipes to put a bit of a sheath over the thread bar to protect the cells from the thread bar, just so that if they do move around a little bit, you don't have the threads cutting through the plastic insulation on the cells. We'll link all of the stuff in the description down below in case you are interested in getting any of it to build your own battery.
So these are the ply ends that we'll be putting here, and they are made from 2 9mm ply glued together. The first one is 230 millimeters, the longer one is 300 millimeters, and they are about 210, 215 millimeters wide. These are 215 millimeters wide with holes 50 mils, the gap of 100, and then the second hole there. As you can see on the top, we've made some handles, and there is this shelf that the bars will rest on for the BMS. We have countersunk these holes a little bit because we usually use longer connector nuts, but we're using shorter ones, and they'll countersink nicely so that it is possible to put this against something without the bolts sticking out.
We always clamp our DIY batteries like this to put the thread bars in, and it's important to note that we are not clamping them with enough force to actually distort the cases of the cells themselves. So we're doing it pretty gently, basically to hold the ply in place.
So a question often asked, how tight do I make these? I'm not making them very tight, because once these are fully charged, these are discharged at the moment, and once they charge up, they'll expand a bit, so adding more pressure. I just put enough that they are definitely going to be held in place. They'll probably, when they are discharged, they'll probably drop out if you were to not have a bottom. So, well, other than the fact that they're taped.
But it's important to note here that we are not tightening them to the point where it distorts the cells or anything like that. It's literally just to hold them so that they don't move.
I am going to put the bottom on now, just because if I do move it over, I don't want the whole pack dropping out, because I haven't made them that tight.
Goes without saying, whenever you're using a drill and or impact driver to push screws into the case of your DIY battery, that you do this with great care so as not to pierce the cells with the screws. And it's important to always wear eye protection when you are working with the terminals, especially putting your bus bars in and other lugs, etc.
So we're going negative, bridging here, bridging there, bridging there. So this will be our main positive terminal. This will be our main negative terminal. The JK BMS, this is a 4 to 8S 200 amp BMS. It has 2 temperature probes, so we'll put those on there somewhere. But it has 9 red and 1 black. So we only need the last red, this one here, and the first 4 red. So 5, 6, 7, and 8, these 4 we do not require on this battery. So what we're going to do is we're going to actually remove them.
It's actually pretty simple to remove the unwanted wires. Essentially you need something sharp. I like to use the probe from my multimeter, and you just push into the side of the clip like that, and it basically loosens the clip that holds the wire into the plug. And you can put these back in the future if you wanted to change to a 24 volt system or something like that. You can push those clips out and then push them back into the plug, and they will work again. So a pretty handy way of removing the unwanted wires. We then cut them to keep everything neat, because there's no point in having really long balance leads unnecessarily. Obviously, if you plan to use the BMS for a potential 24 volt system in the future, then maybe leave them longer. But if you are fixed on a 12 volt system and it's not going to change, then just go ahead and cut them if you want to. Sometimes we'll cut them at varying lengths depending on the layout of the system. One thing to note with putting the lugs on the balance leads is that the color of the lugs determines the size of the lug. So red is generally the smallest, then it goes blue, then it goes yellow. So some people will use the red for the red lugs or the pink lugs for the red wires, and then use the blue one for the black wire. That's incorrect, because the blue lug is actually a different size. It's the wrong size. And it's important to also use the correct crimper for terminating and crimping your lugs. We use this one here, which is specific for these heat shrink lugs, which is our preference to use. We'll link them in the description if you want to get those from Amazon. But it's important to use the correct crimping tool, because even if you use a ratchet crimper for an insulated lug, it may not be the right one for these heat shrink ones, for example. We then put the bars that the BMS will sit on onto the battery, just to get the sizing and the positioning right. This is important to be very careful here, because if you drop that BMS onto the terminals, it'll short. We then measure the length of the black wires, which will go to the B- terminals on the BMS, and we terminated those wires with the correct lugs. We're using 16mm squared wire here, so 2 of those will give us the equivalent of sort of 34 5 mil wire, which is good for the amperage that we'll be able to pull from this battery with this BMS. Once those are on, we put them onto the terminal, put our balance lead on, and get ready to tighten everything down, obviously being careful not to bridge any of the terminal posts, because obviously if you do that you will create a short. We tend to use an impact driver just to nip the nuts up on the terminal posts, which we'll then use a torque wrench to torque properly.
Let me cover the balance leads. You will want to cut them to fit in really nicely, maybe tape them down. Most important will be how you actually connect them. And to have variable length doesn't matter. There's this crazy theory out there that all the balance leads have to be identical length. That's absolute rubbish. They can be any length you want within reason. All they're doing is measuring a voltage, and then when they balance, they transfer charge from one cell to another. Now, the red closest to the black is going to go onto cell 1. So the black balance lead is on the cell sharing with the two black leads that are going to go onto the BMS. So these two are going to bolt onto the BMS, and we have the black balance lead on there. So I've just nipped that up. It's not properly torqued down. I'll torque everything down when it's all tightened. So your first red one will go to the positive of the first cell. Now it doesn't matter whether you put it on this stud of the bus bar or that stud. It actually makes no difference. If it's neater for you to put it on here, then go ahead and do that. But I'm just going to put this down there and use a washer and then one of these nuts, and get it down. You don't really have to have a nut on. I just use a washer on these to stop the balance leads twisting around too much. But on these others, it's quite fine. I just put a nut straight onto the bus bar. It will mark the bus bar. That's fine, absolutely fine. So that's the first bus bar connected. So your next red lead is going to go onto the next one. So I'm just going to put it like this. This is our main positive lead coming off the battery, and we're going to put it down onto the main positive terminal, which is here. You can either have it coming around there, or if you wanted to, you could have it coming out of the handle, but let's just have it coming out of the side. So you could potentially take it out. You could drill a hole here if you want and mount it onto a bus bar on the side. That's fine. We're just going to leave it loose there just for the purposes of what we're showing you here. Now, the last balance lead, so it's the last red one, number 4 plus number 9. They go together to the same lug and they go onto here. So I'm just going to turn these. Right, so we've completed the basic build of all of the balance leads, and all of the bus bars are down. We haven't yet plugged in our BMS. So let's torque these down. It is a good idea to torque these down to the correct torque that will be appropriate for your cells. Most of the cells that we sell are range sort of 8 to 10 Newton meters. And as a rule of thumb, we torque them down to about 9 Newton meters. If it's a very high current situation, then we'll torque it down to 10 Newton meters. We've tested the studs on our cells to about 22 Newton meters was when they actually shear. We think around about 15 Newton meters is when structural damage occurs in the cell from torquing. So torquing these to 8 to 10 Newton meters is absolutely fine. And we've done some stress tests, and there's not really anything in it in terms of heat buildup. So let's get these all down to the right torque.
These Wera torque wrenches are a really nice piece of kit if you're looking for a good one.
I'll need to stop these from turning. There we are. That's torqued.
And then go through and torque each one individually. Often we'll go back over them and just double check because it's easy to miss them, and then you don't really want a terminal that's completely loose, that hasn't been torqued down properly, because that'll be a point that will generate heat, etc., and it can be quite a big safety issue. Next up was to actually put the bars in for the BMS, make sure that it fits properly, and then screw that in, obviously taking extra care not to hit the cells.
So these two bars is where we will screw the BMS down onto. They sit just above all of the studs, so everything is nicely protected. These cables will go around and attach to the BMS, 2 places on the BMS. So let's get the BMS down. Everything here is tightened and finished, so we can safely, it's easy to do this. Let's connect our cables into the BMS. And we want to have this about there so that we can easily get to the various things, switches and what have you. Actually put it smack bang in the middle.
Next up is to screw the BMS down onto the bars. We put all 4 screws. You could get away with just putting 2 on opposite corners, and then you need to bolt the main wires that go from the B- terminals on the BMS to your actual battery outlet negative terminal. So those we just bolt in with an M6 bolt, and we torque those to around 8 or 10 Newton meters.
It's on 8, which is where we had it before. These are the 2 temperature probes, and I'm going to put one and try and tape it onto the cell here. So BMS fully attached. The only thing that we haven't yet done is to attach the system negative going off to our load here and to the chargers, which we'll do shortly. But we're going to put the switch in now and then just try it out and see what it all looks like. So 22, we do it at 11.
If you're placing the switch in a similar place to where we put it here, make sure you leave enough room for the handle so that you don't hit the cables with your hand when you're carrying the battery. We then put in the wires that would go from the P- terminals on the BMS to your bus bars where you connect your charger and your appliances for the load, and we torque these to 8 Newton meters as well. You can torque them to 10 Newton meters if you want to, but 8 is sufficient for the load that we are pulling from the battery. Then put the switch in and tighten that up just using a pair of long nose pliers. You could use a spanner or a shifter if you wanted to, and then plugged in the switch to the back of the BMS.
The moment of truth. We have everything assembled. Here's a positive line, 2 negatives which you'd combine into the same terminal. If we measure the voltage, there should be nothing, or just 1 or 2 volts. So 0.02. It's to be expected. And let's turn this up so that you can see. So now we need to turn that on. 2 short beeps, 1 long beep. So it's turned on and it's red. So let's load the app and we'll click and scan. So we see a bunch of batteries here. There's all batteries around in the workshop, but the one that we haven't renamed, so this JK B2A means it balances at 2 amps. It's 8S, which means it's 4S to 8S, and 20P means it's a 200 amp. So if we choose that, and the first thing we're going to do, let's just come back and rename it so that we click on that, modify name. We're going to call it
Offgrid-custom. Or Offgrid-DIY.
Offgrid DIY, and it will eventually change, but let's turn it off. So I'll show you this thing here. When you turn it off, you just hold this 1, 2, 3, 4, 5, and you see the red goes off. Turn it back on again. Let's come back to the app. We scan again. Wait for it to appear, and it should have changed its name by now. There we are. So we have reset the BMS or restarted the BMS, rescanned the devices, and here we can see Offgrid DIY at the bottom, so we'll choose that. Now, you'll see there's a click to view all alarm. I don't need to do that because I know what's wrong at the moment. So we need to go to the bottom settings and actually set the battery up and then go to control. So let's start with settings. We start off by verifying password. So click on verifying password and we go 1, 2, 3, 4, 5, 6 and click verify. And that gives us the option of 3 different types of battery cells, lithium-ion, LTO, and LiFePOP4. So let's click on LiFePOP4, which will reset all values for default LiFePOP4, of which we now want to change a few. So the first thing we change is our cell count is actually 4, not 8. So you must click OK, and then our capacity in this particular case is 280. Then, just running from the top down, the default Victron, so let's set this up for default Victron. Victron bulk or absorption voltage is usually 14.2. So that would be 14.2 divided by 4 is 3.55. So we need to change our overvoltage protection reset and the overvoltage protection. But we have to change the reset first. So let's go there and change it to 3.5. So that's changed that to 3.5. Now we can change that to 3.55, and that will make it immediately compatible with Victron charge defaults. Now we go down a little bit more, and the continued charge current is very low at 25 amps. So let's change it to whatever you want, but I'm going to change it to 200 because we could, in theory, charge this at 200. So that's 200. The continued discharge we'll leave at 200. And then there are 2 final parameters that we are going to change. The under temperature protect reset, which we are going to change to 5 degrees centigrade. And the under temperature protect, we are going to change to 3 degrees centigrade. So what that'll do is when the cells drop down to 3 degrees centigrade, it will stop charging or stop allowing charge until the temperature rises back up to 5 degrees centigrade. So that is, those are all of the settings we want to change away from the default that we had. Everything is set up, everything is ready to go. We go over to control and let's turn charge on and let's turn discharge on. And if we come back to the status, everything you see charge is on, discharge is on. Balance is actually on, but there's nothing to balance because the cells at this stage are very closely matched. So everything is ready. We now come back to our multimeter and check. We're sitting at 13.28 volts. So the battery has come alive. It's perfectly usable. We can use it. We can charge it. All that remains now is to drill some nice little pilot holes and screw this lid down. And the whole thing is complete and ready to go. Before we screw this lid down, let's talk about top balancing. In the past, with passive balancers, so BMSs that had passive balancing, it was necessary to top balance your cells because the BMS could never actually achieve a decent balancing or if the cells were quite widely out. This BMS in particular is very effective for active balancing. So it transfers charge from the highest cell to the lowest cell when certain parameters are met, which balances them out beautifully. As we can see, the diff at the moment is 0.001, and the fact is these cells are being kept well in balance by the BMS, so we don't need to worry about the top balancing. If you are installing a BMS that does passive balancing, or you're setting very strict parameters that you give a very small window of opportunity for the BMS to balance, then you may need to consider top balancing. But in this particular case, we don't need to. This BMS, with its default balancing parameters, will keep these 4 cells very closely matched. Right, our last step then. Let's drill some holes. Drill 4 pilot holes.
If you are using the same design as us and have fairly thin ply at the top here where you're attaching the lid, then you'll need to take quite good care to make sure that you keep the drill bit straight so that you don't come out the side of your case, just for neatness sake really.
Here we have it, ready to go in. You could choose, if you wanted to put these cables through there, or even drill a hole to run the cables through here if you wanted to. Or you could bring them into a bus bar inside there, or whatever. We'll have the positive cable, 2 negative cables coming out. You could have combined these into one if you want to. There's a number of things that you can do. But basically, this is fully ready to go. We could drop it into a vehicle or a boat or whatever and use it exactly as it is. So, thanks for watching, and hopefully this is useful to you. Cheers.